Sandy Bridge. These are code names of different microarchitecture eras. And I'd like to share with you or explain what it really all means. When we say we're moving from one microarchitecture era to another, it's as if we're just moving from one era of life, of a lifetime for PCs. For if I were to correlate it among the human race, it's as if we had a dinosaur era and a modern era today. So, did you know that Intel re-engineers all computers every 2 years? Again, Intel re-engineers all computers every 2 years. To some extent, people would ask me, Wowie, how could that be possible that Intel re-engineers the entire computer when Intel is only an ingredient, which is just the CPU of the entire machine? So just to give you an idea, did you know that Intel, one way or the other, either standardizes or invented every single component of your PC? Again, right? Did you know that almost every single part and component of your PC was either standardized or invented by Intel? Like, just to give you an example. If you think about memory DIMMs, from the time they were called RD-RAMs, which became SD-RAMs, DDR2s, today they're called DDR3s, every step of the way, Intel standardized those RAMs. When you think about hard drives, from the time they were called IDE, that became PATA, today they're called SATA, every step of the way, Intel standardized these devices as well. When you think about graphic cards, from the time they were called PCI, AGP to PCI, today they're called X16, again, standardized by Intel. When you think about Wi-Fi, from the time they were called 802.11, which became 802.11b, which became A, which became G, today they're called N, Intel standardized it every step of the way. USB ports, invented by Intel. So that's what I mean by almost every single part and component of your PC was either standardized or invented by Intel. So you'll see here on this roadmap that every 2 years, that's what we do. We change the motherboards, we change the entire architecture to bring you the latest and greatest of each machine. Now, if you look on the right-hand side, that's where we are, Ivy Bridge. So, just to help you understand which microarchitectures are, when we say Intel Core microarchitecture, those were the CPUs we used to call as Intel Core 2 Duo or Core 2 Quad. Nihila microarchitecture right down there was the time when we launched the first generation Intel Core i3, i5, and i7 set of processors. Today we are on Ivy Bridge under Sandy Bridge, which actually means third generation Intel Core i3, i5, and i7. Now, on the upper portion of those wavelengths, you'll notice there, I wrote there 65, 45 nanometer, 32, and 22 nanometer. What are these numbers? These numbers represent the size of the transistors we make that we put inside the Intel CPU. The point here is that the more transistors we get inside that CPU, the more powerful your machine becomes. And just to share with you how small that space is, that space where we put the transistors is as small as your smallest nail, your fingernail. Your smallest fingernail represents the case of where we put all these transistors. The only way we can put more transistors is by squeezing that size of each transistor all the way today to as small as 22 nanometer. Now, let me share with you how small 22 nanometer is. But before I do so, when I say nanometer, what's the root word of nanometer? Meter. Nano is the prefix. So meter, how long is a meter in feet? 3.28 feet. So approximately you do this, that's 1 meter. So nano means times 10 to the negative 9, which means divide a meter by a billion, then you get a nanometer. That's how smaller transistors are. To dwell on that even further, to say how small is 22 nanometer, if you get a strand of your hair, huwag na sa akin kasi naubos na sa demo, no? Right. The size of our hair, human hair, Okay? The cross section is about 90,000 nanometer thick. Our hair is 90,000 nanometer thick. Bacteria, if you can see it, is at 2,000 nanometer. Those transistors are smaller than anybody else's blood cell in the entire world. We're only at 22 nanometer today. Right? So, and by the way, the smallest known virus to man is called the rhinovirus, found at 20 nanometer. So again, those transistors are at 22 nanometer today. Now, if you were buying PCs back in the 1990s, our transistors then were worth 180 nanometer. Again, today they're at 22. And guess what? Next year we're launching 14 nanometer. So you can just imagine what will this bring when the time comes. So, and just to share with you as well, I remember about 10 years ago when I joined Intel, when you're a new employee, we usually go to Santa Clara to meet the head of every department there is at Intel. And most interesting was meeting the head of research and development. Back then, he was telling us that Intel's R&D is worth 10 years. What does that mean? Because for most IT companies, R&D is worth 2 years. Meaning, when you say R&D is 2 years, for example, if this is a clicker, no? If there's a new clicker that came into town today, R&D for this device would have been 1 year. Meaning, this was developed a year ago. Intel's R&D is worth 10 years. Meaning, whatever you're buying from Intel today, which is on Ivy Bridge, means that it was developed 10 years ago. And whatever we're doing within Intel labs today are all meant for 2022. So that's how advanced we are in terms of technology. So don't ask me what to expect in the next 10 years, because we would have to kill you if we do. Huh? It's top secret. So the point there is, the smaller the transistors we're able to make, the more we can put it, the more we can slid inside that small space, as small as your fingernail, to create the most powerful CPU today. Now, just a trivia. Would you know how many transistors we have in an AM radio today? Do you have any clue? How many transistors we have in an AM radio today? Guess? Mabibilang niyo lang sa kamay niya. There are about 10 transistors in an AM radio today. Would you have any clue how many transistors we have in an Intel Core i7 processor? How many transistors do you think we have in an Intel Core i7 processor? Any guess? Wild guess?
30.
Sorry?
30.
30 transistors! Oh, may nalaman ba sa 30 transistors? Wala? We only have about 900 million transistors in an Intel Core i7 processor. Just to give you an idea on how small these transistors are. We can get to as much as 900 million transistors to give you the performance you need today. And the best part is, this is Ivy Bridge. And with this Ivy Bridge CPU, brings you a performance that we've never had before, and a battery life so far than what we got used to. So what Lenovo is going to show today are very thin form factors of these new notebooks that are even more powerful and which has longer battery life. You know, the dynamics of buying notebooks based on battery life have changed. Back then, I would presume that when you want to buy a notebook with long battery life, you ask for the number of cells it has. The more cells you have, naturally, the longer battery life you'll have, right? But today we're squeezing down the size of these notebooks. The thinner they are, the less cells that you can only fit in that machine. So my point here, with less cells, you actually get longer battery life only because of our technology under the Ivy Bridge microarchitecture era. So with that, I'd like to congratulate Lenovo for bringing us the latest generation of machines. Thinner, more performing machines, more powerful, and longer battery life. So again, thank you.
Thank you, Sir Wowie.